So hi everyone. So today we'll cover from GATE 2011 to 2015 the chemical kinetics topics. Okay. So in last video I completed from 2016 to 2021. So these are last video of chemical kinetics from GATE perspective. Okay. GATE previous year question. Okay. So today we'll solve 7 question or 8 question. So in this question and the levels are that not that much difficult, so we'll start. Okay, so first question that came in gate 15. Okay, gate 15. So what is the question? That is the expression for the equilibrium constant for enzyme catalyzed reaction given below. Okay, this is the reaction. So here E is the enzyme. Okay, S is the substrate, ES is the intermediate one, and P is product, and E is again the enzyme. So they are equilibrium, and they are asked for the expression for the equilibrium constant for whole reaction. Okay, so in first reaction we can see that E plus S to K1 to K2. Okay, it's a sorry, K1 and K2. K1 is the forward rate constant, and K2 is the backward rate constant, that goes to AES. Okay, so for this K1 equilibrium, or we can say K equilibrium 1, that is K1 by K2, forward reaction by backward reaction. Okay, for the next step, so that is ES in equilibrium with P plus C, here K3 by K4, where so now that is the K equilibrium 2 is, it's not square actually, it's 2 only. Okay, it's better to write in it, let it in, okay, 1 here, 2 here. Okay, now it's not confusing, so it will be 3 by K4. Okay, so now the whole reaction equilibrium, so that will be K1 by K2. What is K1 by K2? That is E by S by ES plus E concentration, obviously S. Okay, and K3 by K4 will be P is not actually plus, here it is multiply P E by ES. Now if you multiply K1 equilibrium into K2 equilibrium, then we will get our equilibrium constant for the reaction, whole reaction, that will be K equilibrium will be K equilibrium for first reaction into K equilibrium for the second. How it is? Why I am saying like this? Because if you multiply this one and this one, so ES by E into AS, so that will be ES, that is P and E. Okay, so here ES and ES is cancelled out, so it will be P to E by E to S. You can cancel out the E also, because the at the last and the beginning and the last, the concentration of the enzyme also same. Okay, so it will our answer. So that is K1 by K2 into K3 by K4. Okay, this is our answer. What is the answer? So A will be our answer. Okay, so our next question that came in gate 15. Okay, so what is the question? The process given below the follows Langmuir adsorption isotope. Okay, to absorption, means it's a dissociative, okay, dissociative in nature. So if the theta denotes the surface coverage and p denotes the pressure, the slope of the plot 1 by theta to 1 by p, okay. Dissociative means, I told that in my previous video, so we can write in dissociative reactions like theta will be according to Langmuir adsorption, that is kp by 1 plus kp if it is not dissociative. For not non-dissociative, dissociative, okay. For dissociative reaction, theta will be kp by kp to the power 1 by n and 1 plus kp to the power 1 by n, okay. N is the number of atoms in the molecule, in that molecule, or we can say that in number of parts the molecule divided, okay. Means from A to, there is 2A, so in 2 parts it's divided, so it can be like that. It's not number of atoms, like we can't say like number of atoms in that A, so we can say that number of parts that a molecule divides, okay. So here it is 2 parts, so it's dissociative in nature, so that will be N will be here 2, okay. So theta, it is n2 is equal to, so it will be theta is k p to the power 1 by 2 by 1 plus kp to the power 1 by 2. So it asks that 1 by theta versus 1 by root p. So 1 by theta is 1 by k p to the power half plus 1. So that is, what is the slope? They ask for the slope. So slope will be 1 by k to the power half into 1 by root p plus 1. So this is our slope, because this is x, this is y, and this is c. So slope is 1 by k root k. 1 by root k means D will be our correct option, okay. So our next question, that is GATE 2015. So this question, the gas for unimolecular reaction temperature, the pre-exponential factor, this one, the entropy activation, we did it in my last video, and that is for bimolecular reaction. Here it is, so here it is a unimolecular reaction. So for unimolecular reaction, for unimolecular reaction, I said that the pre-exponential factor for the, according to the activated complex theory, the pre-exponential factor will be A is equal to k T by H e to the power 1 minus del Ng, okay, e to the power del S by R, okay. For bimolecular reaction, there will be a extra term, the whole term will be the same, and the extra term will be C0 to the power 1 minus m. It is for only the unit. For bimolecular reaction, the unit is different from pre-exponential factor. So to cover this that unit, so to maintain the unit, so we multiply the whole term with C0 to 1 to the power. So it's a standard concentration, okay. So if we did the Ng is equal to delta Ng, that is 1 minus m. M is molecularity. Here it is unimolecular. Unimolecular means 1 minus 1, so that will be 0, and e to the power means 1 minus del Ng is equal to 0. So e to the power 0 will be 1, so this part will be 1. So we have kth e to the power del s by r. Okay, a here, a is 2.17 into 10 to the power 13. You have to maintain the unit also here, so second inverse. Okay, that is kt, this one, because this term is unitless, so these have to be same unit with a. So this is second inverse, so kt, if you write the equation, 1.38 into 10 to the power 23 minus 23 actually, so that is in joule per Kelvin into T. T is 298. Okay, 298, that's okay. And e to the power del s by r, had in the denominator the h will be 6.6 into 10 to the power minus 34 joule second. Okay, that is Kelvin. So Kelvin cancel out, joule cancel out, so it will be 1 by second, so there is second inverse. So if we do that, so del s by r, if we calculate this one, so that will be 2.17 into 10 to the power 13 second inverse by 6.23 into 10 to the power 12 second inverse. So second inverse cancel out. So if we take ln here, ln, so if we take ln here, so it will be del s by r, so del s will be r ln this term 2.1317 into 10 to the power 13 by 6.23 into 10 to the power 12. So if we calculate this one, this will be 10.37, and the unit will be the unit of r, that is joule per Kelvin mole inverse. You just have to remember this equation only, this is important. Okay, you just have to know that for greater than the, if the molecularity is greater than 1, then this term will be the extra term with this equation. Okay, for unimolecular this will be enough, this equation will be enough. Okay, so our next question that came in gate 14. So what is the question? That the monoatomic gas X adsorbed on a surface follows the Langmuir adsorption, and the plot of fraction of surface coverage theta against concentration of X for very low concentration. Okay, so for Langmuir adsorption we know that theta will be Kp, so P is the pressure of that, here it is concentration, the P is the partial pressure, so here X will be the concentration, so the equation will be K X by 1 plus K X, and here it is said that it is very low concentration is given, so X very low concentration, so this term will be very less, so hence Kx is very less than the known condition. Okay, condition given, so this term will be 1 plus K X will be 1, so theta will be K X by 1, that is Kx. Okay, so our equation will be this one, theta is equal to Kx, because it's asked for the very low concentration. If it is asked for very high concentration, then for very high concentration, concentration, then in that case kx will be highly greater than equal to 1. So this term means 1 plus k x will be kx. So for that case theta will be kx by 1 kx, that is 1. So you can say that for the very low concentration, this reaction means coverage will be, surface coverage will be of first order, okay, because the x term is will there. And for high concentration, it doesn't, the surface coverage will not depends on x, the concentration, so it will be in zero order. You can say. So next question. So next question is from gate 13. So the question is the reaction of type x to y, forward rate constant is k1 and backward rate constant is k2. Okay, the rate expression is x0 and x correspond to the concentration of x at time t0, okay, respectively. They asked for the dx dt minus dx dt. So x to y, this is given, k1 is forward rate constant and k2 is backward rate constant. So at time 0, time is equal to 0, the concentration of x0 is 0 and it is 0. Why? Concentration is 0 and at time t0, at time t, after time t, the concentration is x is the corresponds to the time t, that will be x. Okay, so how much the concentration, what is the concentration of y? That will be x0 minus x. So because some amount of x will convert to y, so the concentration of y will be this one. So they asked for the minus dx dt. So minus dx dt will be, if we write minus dx dt, or we can say if we start with dx dt only, okay. So if we start with the dx dt, so in this case, first case, in forward reaction, x is converted to y, so it will be minus k1 x. So why I am writing here x? Okay, because we know that the rate at any time, it depends on the concentration of the reactant at that time. Okay, so concentration of that means concentration of that substrate. So concentration of this one is not reactant actually. If you want anything, if you concentration of y depends at that time, the rate depends on that time, that concentration, and that also for the x. So at time t, the concentration is y, x here, not x0. So and for the backward reaction, x is reversed back, means from y to x is producing. For that k2 will be, for that x0 concentration of y, so that is x0 minus x. Simple. Now you do the equation. So minus k1 x plus k2 x0 minus K2 x. So if you do that, minus K1 plus K2 x plus K2 x0, but it in every option it's that there is a minus in dx dt, so it will be, it is dx by dt, so minus dx dt will be K1 plus K2 x minus K2 x0. Okay, this is our answer. So what is the correct option? That is K1 K2 x, K1 plus K2 x minus K2 x0. So this B option will be our correct option, because in every case you can see that here x0 is not x, here it is minus, not will, this is not correct, this is also not correct, and this one is not also correct. Okay, so option B is the correct option. So next question that came in gate 13. So what is the question? So for the first order consecutive reaction PQ to R, PQ to R, okay. So for steady state approximation, Q, concentration Q, the variation of PQR with time are best represented by U. For steady state approximation, we consider the intermediate, the rate of producing intermediate is 0. Means here intermediate is Q. So here in this case dq dt will be 0 according to steady state approximation. Okay, dq dt will be 0. If your dq dt is 0, so for that case means the concentration, means if the rate constant for this reaction P to Q is K1 and Q to R is K2, then for that rate, for that one, the condition will be K2 will be much faster than K1. That case only, means from P Q is producing and from Q R is producing, but if K2 is much faster than K1, then means it's some amount of Q is produced. After that, that means at very less time that Q will be converted to R. So means in the reaction box, the concentration will be concentration of Q will be very less, because K2 is very large than K1. Means the decaying rate constant is very large for Q than the producing rate constant. So for that case concentration will Q will be the minimum, we'll get the concentration of Q will be as a minimum. So we can state that, we can say that see that option A, the concentration of Q is this one at such time. So this will not be this is maximum actually. Okay, this is not the correct option, because in that the condition in for this graph the condition will be K1 is highly greater than K2, but our condition is K2 to K1, K2 is greater than of K1. Okay, in that also B is not correct. Minimum is for C. You can see that the concentration of Q is very less for that Q, means for that graph. So this will be our correct option. In that also in D, this is not the minimum. So option in C is the correct option. Okay, so our next question is from gate 12. There is one question only from gate 12. So the consider the reaction from hydrogen plus ethane to methane. sorry, methane is ethene, CH2 double bond CH2, and this one is CH3, ethane, CH3. Okay, so the pre-exponential factor in the rate constant calculated using the collision theory. In that question, it is pre-exponential factor according to the activated complex theory, the entropy of the activation. Okay, activated complex theory, but in this case it is asked for the collision theory, pre-exponential factor for the collision theory. Okay, in this MQ, this unit is approximately, so what is the this one? Okay, they ask for the pre-exponential factor. Okay, so what is given? This term is given, that is 1.11 into 10 to the power 27, this unit, and where the symbols are the using meaning, the at reaction temperature is 300 Kelvin. So for the collision theory, according to collision theory, the pre-exponential factor will be is A equal to 8 kT by pi mu to half Na pi d square. Okay, so this term is given 8 kT by half pi mu. This term is given. You have to calculate this term only. What is d? D is the collision diameter. Collision diameter means the molecular diameters of H2 is given. D of H2 is 1.8 angstrom, and that is for C2H4, that is 3.6 angstrom. So what will be the D here? In this case, D collision diameter will be 1.8 plus 3.6 by 2, because what is the collision diameter? If two molecules collude to each other, so if this will be our collision diameter from that case, so whole will be, so that is means half of it is H2 you can say, and this will be C2H4. The collision diameter will be this one, so half of C2H2 and half of H2, so that is 2.7 angstrom. Okay, so just put it here in the equation, that is this term is given, that is 1.11 10 to the power 27 into pi. Pi is 3.14 into d square is 2.5. Angstrom means it's, you have to convert it in meter into 10 to the power minus 10 meter, so that is that cube only. So if you calculate this one, so you'll get 2.5 into 10 to the power 10, and the unit is this one, m cube. Okay, so option A will be our correct option. So you just have to know the what is the pre-exponential factor according to the collision theory. So that is this one, nothing else. Okay, so our last question that came in gate 11, so that is lengthy question but very important question, because this even come in our course exams, means our semester exams. So you have to, that is calculate the decomposition of ozone to oxygen. Okay, you have to calculate the rate. Okay, D3 DO3 dt, and our second question with that one, if the condition is given, the what is our activation energy. Okay, so we'll start. So this is our three, okay, sorry, this is our three equations. So you can write this equation here for your convenience, that is M plus O3 to K1 O2 plus O plus M. This is our first equation, that is the first one, MO3 O2 O Mg. Okay, second is O2O M to MO3, that is O2 plus O to M plus M, that is net constant is K2, so M plus O3. The third one is O plus O3 to O2, O plus O3 to 2O2. So these are three equations. So you have to calculate the, so you have to follow the steady state approximation. So for that you have to consider the 0 for the rate of the intermediate, rate of production. So that will be dO dt. dO dt is our, O is our intermediate. So dO dt will be, for first equation, dO dt will be K1, because here intermediate is producing, K1 M O3. For the second reaction, O is means intermediate is decaying, so minus K2 O2 O M. Okay, for the last one also decaying intermediate, that is K3 O and O3. So you have to according to steady state approximation, dO dt will be 0, this one. So from this equation we can write what is O, means concentration of O, that is K1 M O3 by K2 O2 M. Okay, this is our concentration of O. So now the rate according to dO3 dt, we have to write the dO3 dt. dO3 dt, what is that? That will be, from the equation we can write that this one, because in the first case O3 is decaying, so I will write K. So not dO3, we will first calculate as a plus dO3, so we can just remove it. So that is K1 M O3. Okay, so in the second one it is also it is producing, so it will be K2 O M. In the third case it is decaying, so it is minus K3 O3. So now we'll substitute the concentration of O in each case with this one. So if you substitute it, K1 MO3 plus K2 O2M is there and O2, so that will be K1, sorry, I will write K O2M first, then we'll write for a K1 M O3, we'll substitute the O for that and allow K2 O2 M plus K3 O3. Okay, minus this term is K1 K3. We'll write the result, that is here O3, here also the O3 square will be there, so O3 means ozone the square, that is M by the K2 O2M plus K3O3. So now if we do the simplification, so that is 3O3. Okay, this term is remained. So the first term will be multiply this one to this one. Okay, so will be two terms. So that is minus K1 K2. The first term will be O3 O2M. Okay, O3 O2 M, here M is also there, the M square. So the second term will be minus of K1 K3 O3 square M. Okay, so this term will be here M, there is 2M, so K1 K2 plus K1 K2 O3 O2 M square. Okay, and the last term will be minus of K1 K3 O3 square and M. Okay, so you can see this term and this term is same, but they are opposite in sign, so this term will be cancel out. So our option is 2 K1 K3 O3 square M by K2 O2 M plus K3 O3. So this is our expected result, that will be dO3 by dt. So here it is minus dO3, so we'll just do it here plus, and it is minus. So this is our expected result. Okay, so here 2 K1 K3 O3 square, so option will be 2 K1 K3 O3 square, and in below side K2 O2M plus K3 O3, K1 K3 O3 M square K2 O2M K3. So option A will be our correct option, K2 O2M plus K3 KO3, K2 O2M plus K3. So this option A will be our correct option. Okay, so our next question, that is according to this one. So KO3, the condition is KO3 is much greater than the KO2 in the in denominator. Okay, so condition is given that K2 O2 M less than of K3 O3. So this term will be minus dO3 by dt will be 2 K1 K3 O3 square M by, if this one is much greater than, so this term will be only K3 O3, because this term is very much less. So now in this K3 O3, so K3 3 cancel out, it will be 2 K1 and O3 also cancel out, so 2 K1 O3 M. For this one, what is the activation energy? So we have to, so you can see that the rate constant is only depends on, for this rate reaction, rate constant is depends on only K1. So the activation also depends on the K1, so that will be KA1 for the first reaction, that is KA1. So option D will be the correct option. So if we do the can see Why? Because it's only depends on the rate constant of K1. So the activation also depends on the K1, because from if you substitute that, the K1 is K1 is A e to the power minus E A1 by RT from the Arrhenius equation. So it's only depends on only A1, means K1. So our activation energy will be EA1. So by this, so I completed from the all the gate questions, previous year questions from 2011 to 2021. So in my next video, we'll cover the previous CSR exams. Not everyone, but the different questions only. Okay. So previous year questions will complete. So by this, okay, I'm ending this video. So if you like the video, please subscribe my channel and tap the bell icon for that you can you'll not miss our future videos. Okay, thank you. Bye bye.